Hello and welcome back to the Tin Barn again. I'm Pragmatic Lee. This video is going to be part 2 of the 2x72 belt grinder. In this part we're going to look at the T-handles and T-nuts. Alright, as I said in this part 2 of the video, we're going to look at the creation of the T-bolts and the nuts. And as I explained in this part, I could have very easily just welded a cross piece on the end of a bolt and use that, but I decided to go with something a little bit more, I think, dressier. It's entirely up to you, but these two will lock the plating and the work table, and then this one up here will lock the tracking roller. And I mentioned in there that I may have to put a lock nut on there, and I did, but this is threaded long enough. This goes all the way through, and this has a lock nut to keep it from vibrating when the unit is running. In this video you'll see where I had panhead screws in holding this on. But to use that lock nut, I needed to, well, first off, that didn't look that good. Panhead sticking out there. And I needed the space on the threads. So I counterbored and put, I believe they're 1024s I used in there to hold those. So we'll move on to that part two of the video. I'm going to need some T-handles to tighten the plating on its shaft down, and also the workbench that'll be also will be retractable, and also need a T-handle for the alignment pulley or the alignment roller at the top that will tilt it in and out. Now I could take a just a standard half 13 bolt, weld a handle on the end of it, weld a T on the end of it, and call it good. And that would be perfectly fine. That's what most folks do. But I think I want to go a little bit different. I've got the mill and the lathe, and I enjoy using them. So what I'm going to do is just using some hardware store hot roll here. Going to dress these up. Dress up the ends right now. I will eventually mount this end to there and thread the end as necessary. To start with, though, of course, going to clean up the ends of each one. So I'm just going to put these in the mill. This longer piece right here is going to be the adjustment for the tracking roller. So it will need to thread or pass through the housing, and then also have a threaded portion back here, and then the T back there. The actual length on it is really not crucial, or doesn't have to match anything else. So I'm going to just go with the saw length on this piece. Now the remainder of the pieces, the handles and the body of the T itself, I want these to be 1.5 inches, so I'm going to move my mill stop in, or a vise stop in, just to get a set point. And these don't have to be down to the thousandths at all. I just would like for each one of them to be close to the same length. So I'm going to make a dress up pass on that. Let's see. a pretty good saw cut. It's hard to tell which one was that I actually milled. All right. While we're right here at the mill, I want to go ahead and take all three of my body pieces and drill the hole for the T in them. Got 1.5 inch pieces mounted back in there now, and what I'm going to do is locate the center. Alrighty, I'm going to deburr these pieces now, carry them over to the lathe, and then I'm going to drill and tap this end, the whole end of each piece, for a 1/4-20 grub screw. Alright, the champering, the end of my champering tool on that side was needs sharpening bad, so I've turned it around using the other side. And all I'm doing, again, is just putting about like a 45-degree chamfer on there. See if I can get this out of the way so that you can see what's happening. Then I'll take the file. Now, I'll continue to do that process. I will loosen up my collet. Turn the piece around. So I'm going to continue this process for both ends of the 1/4 inch T handles. And there's what our T handles look like, just some relief on the end. But what we're going to do now with a 1/2 inch is put them in there. We're going to chamfer this end just a little bit. We're not going to try to make it round, just going to chamfer it. Then we're going to drill and tap the end for a 1/4-20. I'm using the bottom tap to finish that hole out. Okay. Now we'll take this one out. And the long piece in, if such a piece was needed to be worked on. So I'll do the same procedure on that, and then we'll turn this piece around and turn the end of it down so that it'll pass through a nut. So we've got about 100 thousandths to take off of this piece. I do have my carriage stop set at 2 inches. Now that should pass through a 1/2 inch nut, which it does. That's all I was looking for. On this end down here, we do want to make that reasonably rounded down here. And again, this is going to push up against the housing for the tracking roller. So I want a little bit of a round end on that, just to have more contact surface. So I'll start out with just a simple 45-degree chamfer on it. Alright, I'm going to get the change gear set up to cut a 13 threads per inch thread in this, well, all 3 of these pieces. Alright, I have one of the T-handle pieces in here now. I've already threaded the long piece. As you can see, this part will pass through the housing. This will ride on the threaded part of the tower and the T-handle in here. I have in here now one of the short pieces, and just like the long piece, we want to thread about 1 inch, but we're going to thread this on the end. So I'll zero out the DRO, come in 1 inch, and we're going to put just put some thread relief in there. Now I already have the change gears in, so, and I've tested it. They are the proper gears in there. So I'm going to put a little chamfer on this end down here to get us a start. And I will file that as well after we get the threads cut. So I have my threading tool. Set the compound at 0. And we're going to turn on just enough to I'll set the 0 on the cross slide right there. And 0 out the DRO as well on that axis. Alright, slow it down just a little bit. And I'm waiting for my number to come around. This is an odd number thread, so I can't use every number. I'm taking about 5 thousandths at a time on the compound. If you back off far enough, if you happen to miss your number like I did right then, you got plenty of time to disengage and wait for the number to come back around again. Alright, I'm using the old formula of 0.750 divided by the threads per inch, which in this case was 13 threads per inch. That gives me 57. I'm coming up on, I think this will be 50 on the dial right now. I can't remember whether I advanced or not. Worst case, it'll be a spring pass. Yeah, I had not advanced, so. Alright, this is going to be 55. And then we'll try the nut. And I'm going to make a spring pass on that one. And I'm just going to burnish it a little bit with the file. Alright, let's go that 2 more thousandths there that the formula called for. I may have boogered the end of that thread a little bit with the file, but this will definitely clean it up. And again, being the last one, we'll make a scratch pass. So far, that's looking like a good thread. Alright, I had to make a couple more passes on there, clean up. I had a burr on the end down here, and it took a couple more passes to clean that out. We'll clean it up. The nut goes on there fine now. Good fit. Alright, all the pieces of our T-handles are done. Got the set screw, grub screw in the end of each one. Got them threaded. This one will have a nice little round end to it. And here we've got a good flat end for the pressing up against the inner square tubing. So now we'll put our T-handles in. And I'll probably, these set screws, grub screws I have here are a little bit long, so I will I'll pick up a couple more or some shorter ones of those. But personally I think that looks a little better than piece of bar welded onto the end of a bolt. But again, that works perfectly fine, and that's what most folks are using. There we have the T-bolts for this project. The T-handles we just made also, of course, will require a nut. And just like I could have welded a cross piece on a bolt and use that for the T-handles, I could weld a nut on to the side of the housing for these to thread through. But I'm going to do this a little bit different too. This is another piece of that Mr. material stock. I'm going to turn this down to 1.5 inches. We're going to make 1.5 inch round nuts that will screw onto the side of the housings. So I'm going to turn this down a bit and bring you back when I get a little bit closer. Okay, we've got 50 more thousandths to go. So we'll take that. Alright, now we want to drill that for 1.5 inch 13, which is going to be a, I believe that's going to be a 27/64 bit. Anyhow, I'll get that bit and get it set up to drill that. Okay, I have the 27/64 bit in there now, and I'm going to drill this in a ways. We're going to part this off in 3/4 inch pieces, so I'll drill enough to maybe to get 1.5, something like that, and then drill and part until we've got 3 pieces. Okay, I carried it over to the bandsaw after I got them drilled. Cut off our 3 pieces. We're going to put that in there, clean them up, and turn them down to 600 thousandths. I'm going to chamfer that edge, then I'll turn it around to get to face it down to length. And I'll continue this process until I have all 3 of them down to 0.6, the edges on both ends chamfered. I'm not going to thread them on the lathe. I don't think I am. I'm going to carry them over to the hand tapper. I'll carry the camera over there, and I believe it'll just be easier to tap it over there. Well, folks, I've spared you to the agony of watching me tap these 3 nuts. If I'd had any idea my 1/2 inch taps were that dull, and I've got about 6 of them over there, but either that's some mighty hard material on the inside. I think the problem was my taps are just dull. But like I say, I spared you the agony of having to watch me struggle through that. But I got the 3 of them tapped. Now what we're going to do is put 4 holes in here that will be used to screw this, mount it to the hollow structural steel frame. And what I'm going to do is just using this this little pointed center right here, I'm going to find 0 with it. This is not crucial enough to require getting the coaxial indicator out or any kind of indicator. just need to get that on center. I'm going to zero out the X and the Y, and then what I'll do is come a 1/2 inch on the X this direction, 1/2 inch on the X that direction, 1/2 on the Y, and 1/2 on the Y in each of those two directions, and drill a 3/16 hole. Be using a 1032. I'm sorry. Let's see. Is it a 1024 screws is what I'm using. So I'm going to go through and center drill all of these to begin with, and we'll start out by locking the X down. And I believe it'll be just as simple to change the tools out as it will be to go through and center drill everything and then come back. And then this will be screwed onto the side of the hollow structural steel. They'll be bolted on as such. If any of this protrudes through the steel itself on the inside, of course I'll take the Dremel tool and clean that out. And I'm going to continue that process on the other two, deburr them, and then I think the nuts will be finished. Okay, all of our nuts are done now. Our T-handles and the nuts, and they will mount on the side of the structural steel, the HSS hollow structural steel, as such. Again, any of the bolt that happens to stick through this, remember we'll have a male piece sliding in and out of here. If any of the threads stick through, we'll just use the Dremel to clean those up. And I think these T-bolts and nuts turned out quite well on there. I've actually got a coat of sprayed clear coat on these to keep these from rusting. In part 3 of the video that will be coming out in a few days, we're going to look at the actual structure or the frame of this belt grinder. Keep an eye out. In a few days, be back with part 3.